Okay, so now we are going to look at parallel lists. Your book does touch on this concept, but they don't really spend much time on it. So basically, I have my original smoothie list of flavors, but I've added two parallel lists here in parallel with those original flavors. So we have a calories list, which contains the calories per smoothie, per serving, or whatever. And you know, I should note here that order matters. You have to be careful. So the first flavor, for example, is Blueberry Bliss. That has 340 calories. The Lean Machine has 490 calories. Mocha Madness, 660 calories, and so on. So it's up to you, the programmer, to get the correct calories with the correct flavor in the correct order. Okay, Python's not going to know that you switched them or, you know, put the wrong one with the wrong one. So you need to populate your lists very carefully. So I have the calories list, and then also I've added a protein list, also in parallel with the other two, that contains the grams of protein per smoothie or per serving. Okay, so now my lists are populated, and I will print the menu. I'll run that and show you, and then we can kind of dissect the code here. Okay, so I have these are just headers here that I've hard-coded, but this is where the interesting part is, where I'm looping through the lists in parallel and just pulling data from the lists and printing them row by row, and using the alignment technique that I introduced in the last video here. So let's take a look at this. It's not a lot of code. So this is all header stuff. I just like kind of hand coded that and eyeballed the spacing and just kind of fiddled with it and got it looking good. So there's that. But this is the loop here. So I just used the for loop with a range variable, again, mapping that to the length of the smoothies. I mean, I could have used any one. Now we've got three lists in the mix here. I could have just as easily put calories in here. Okay, they're all the same length, so I'm going to get 10 no matter what in this case. So we have our loop counter I. All right. Now I want to show you something. I have this original line of code. I'm just pulling from each list here, okay, using the loop counter. Just doing, like, once you have a program that loops through one list, for example, it's really easy to just add parallel lists. It's like the plumbing is in place, okay? Now it's easy to just add lists. I can add another one with the fat grams. It just wouldn't be a big deal because all the plumbing is in place, as I like to say. So let me run this. You can see this is not going to look at, so it's like that alignment that I talked about, and I'm going to add that back in just a moment. When you're dealing with like columns of things and you want them all lined up nicely, just like tabbing between them is not going to cut it, right? So that's not going to work here. So let me put the improved version back in. And so you remember from the last video, I can format a print field. I'm saying, you know, the colon says, hey, wait a minute, I'm not done. I need to format this. And in this case, the smoothie names are longer, so I'm putting those in a column 20 characters wide. I am left aligning them. I talked about that in the last video. It's conventional to left align text data and then right align number data. You don't always have to do that, but that's what I'm doing here. So I'm left aligning. Look, that left pointing arrow means it's left aligned in a 20 character field. Okay, and so that's the smoothie name. And then for the calories, I'm back to right alignment because those are numbers. Those are obviously not as long, so I just have those in 10 character print field, and then same with the protein. That's the same type of alignment there. So yeah, as I said, it's easy. Like once you get one of them down pat, it's easy to just add parallel lists to add more data to your program. Now I've got a couple more techniques I'm going to throw into this video as well. So we have these min and max functions that will allow us to find minimum and maximum values in a list. So let's find the minimum calorie smoothie. Okay, so you know how cafes are. Sometimes they'll make, they have specials, or they'll make recommendations or something. So let's say we want to tell people to try the skinny option, which is only X amount of calories. So what I can do is call the min function. Okay, I'm passing it the calories list. It's going to find the minimum value in that list, or I should say the first occurrence of the minimum value in that list. Now, it's not a big deal here because it's going to be this one, actually, the Blueberry Bliss, and there's only one of those. So we really will get, the lowest calorie, the one and only low calorie option, or lowest calorie option, I should say. There are a couple of here. This one, Sunrise, Sunset, and Peaches and Silk, those are both 360 calories. So it's like it wouldn't work if you've got duplicates, but it works in this case. So let's just go with it. So that's going to get the minimum calories. Okay, it's gonna, what's gonna go into this variable here? 340. It's just looking for the value, the smallest value in the list. And that's 340 if we're talking about the calories list, 340. So I've got a 340 in here, all right? So what I can do is find the index of that value, meaning the 0 through 9 number that locates that value in the calories list, all right? So here I'm passing it the 340 basically. All right, and using the index method, which I don't think I've talked about yet. You do see this in your book though. But so the index allows you to find the index of a specific value. In this case, I'm looking for the index. Where exactly in that list is the 340? Because once I have that index, which is actually 0, it's the Blueberry Bliss. It's the first one in the list, okay? But it doesn't necessarily have to be. Once I have that, now it's in the min-cal index variable, and now I just plug that into, I can get that. Once I have that index, whatever it is, 0, 1, 2, 3, whatever, I'm home free. I just plug that into each of the arrays. I can say, try our skinny option, plug that min-cal index into the smoothies array to get the Blueberry Bliss, and then the calories, from the calories array. So let me just go ahead and run that. Okay. So again, you can use min to find the lowest value, and then use index to pinpoint the index of that value. Okay. And then once I have that index, I'm home free, just plug it in, and I can pull that data from whichever lists I want. Okay, so let's do the same technique, but this time with the protein. This is the maximum. So I want the maximum protein option for people who are into lifting and building muscles. So let's see. So I'm using the max function on the protein list, and that is going to put whatever the highest grams of protein are, that is going to go into max protein. Let's see exactly what that is. So it's 15, whichever one that is. I don't know. I think it's the triple berry oat, actually. So it's 15. So that's going to put a 15 in the max protein. And then I'm going to turn around, and from the protein list, I'm going to call the index method, which will return the index 1 through 9 of that 15, that value of 15, which is the highest grams of protein. So once I have that, I'm home free. That's in the max protein index variable, and I just plug that into my lists and just pull the data right out. So let's look at the output there. Okay, so our triple berry oat. So just pulling that right out of the smoothies list. Okay, and then pulling the protein out of the protein list. So yeah, very useful methods there and functions for accessing data in your parallel lists.